In this video we're just looking to compute eigenvalues of a matrix. So we have our matrix A. This is the identity matrix, and the values of lambda that satisfy this equation are called our eigenvalues. Okay, so let's just get into an example. And det stands for the determinant. If we have a matrix A, it's equal to 2, 2, 5, minus 1, then A minus lambda I is equal to 2 minus lambda 2, 5, minus 1 minus lambda. Okay. Now we want to find the determinant of this in terms of lambda. So I'm going to go over here. The determinant can be written with just these almost like modulus looking signs around the matrix. Right, so this is equal to the top right and bottom right things multiplied together. 2 minus lambda minus 1. Oh god, it's gone terribly. My lambda looks like a 1 and my 1 looks like a lambda. Anyway, 2 minus lambda minus 1 minus lambda. There you go. And then minus 2 times 5, so that's minus 10. And that comes out as equal to lambda squared minus lambda minus 12. To find our values of lambda, we want to solve this equation, which is this polynomial, and this polynomial we call C of lambda, by the way. This is called the characteristic polynomial, and that's just the polynomial you'll get when you write determinant A minus lambda I as a polynomial on lambda. Okay, so that's the characteristic polynomial. We set that characteristic polynomial equal to 0. And we solve for lambda, and we're going to do that by factorising. So lambda plus 3, lambda minus 4, so lambda is equal to minus 3, or lambda is equal to 4. So these are our two eigenvalues. Now, the amount of eigenvalues you get will depend on the size of your matrix. So this is 2 by 2, so we get 2 eigenvalues. But if you got 3 by 3, you get 3, provided you don't get any repeated roots in these equations. If you get repeated roots, then you might get a different number, but you can't get more eigenvalues. Anyway, so in the next video we're going to look at eigenvectors, so we'll quickly just see what defines an eigenvector, and then in the next video we'll find the eigenvectors for this matrix. So if we do A times some vector V and it's equal to lambda multiplied by vector V, then V, and both these V's are identical, is called the eigenvector. Alright, so the eigenvector is a vector that, when multiplied by the front from the matrix, then it's just equal to a scalar multiple of itself, and that scalar multiple is the eigenvalue. And when we say eigenvector and eigenvalues, these are all eigenvectors and eigenvalues of the matrix A. Alright, so it's important to remember that. But that's it for this video. Hopefully I'll see you in tomorrow's video where we'll find these eigenvectors, look at the method for doing that. If you did enjoy, please like and subscribe, and I hope to see you in the next one.